Okay, gentlemen, start your engines. We're back onto the rapid tailstock, that mechanism that moves a drill chuck quickly. All right? We're talking about this is part number 2. The part name, pivot clamp. You see the little game plan signs on each side of the pivot clamp? That's what I'm going to do. I'm going to plan on how to make part new. I call it paint by the numbers. Hang on. Alright, you're in my CAD system. I call it my scribble sheet. I put all kinds of stuff on here. Alright, back to it. Rapid tailstock. Let me give you a little background to get you up to speed, and then we'll go on to part number 2. Part number 1, right? Here's the whole mechanism. You've seen it before. You pull this lever, this drill chuck advances 3 inches. Alright? Say it again, Sam. Alright? So here's what I'm showing. Let me just highlight part 1. You see one here where the mouse is? And here, that's all one part. Morse taper shank. This one's called the body. Part number 1 is the body. Now we're going to move on to the thing it's called pivot clamp. This clamps around the body. Let me bring you over to another view of the pivot clamp. See it here? This is called a pivot clamp. Alright? You looked at that view there, but here's a page view. There's where all the detail is. Alright? You can see that this bore goes around the body and it gets clamped. Let me move this as a utility. I'm going to put that screw right in where it belongs. Hang on. You all know how this works. You can see that this happened to clamp. It's got clearance for the body of the screw. This happened to clamp. It's threaded, 1/4 20. When you tighten that screw, this thing closes up. You see it? You know, that's typical. I'm going to show you a little something wonky here, though. You see this slit up here? Well, this is a 1/2 inch hole here, right? And this is a 1/4 inch slot. You see it? Why such a large slot? Well, how'd you like to put a slitting saw through 3/4 of an inch and do that when you don't have to? This here, I take a 1/4 inch end mill, right up the middle, dead center, right? Up into here where there's clearance, right? I go 3/8 of an inch deep. Why 3/8 of an inch? Because this thing is 3/4 of an inch deep. So in a vise, I'll flip this sucker over, and I'll do the other half 3/8 of an inch. Easy way to get it done without all the slitting saw issues. You see what I'm talking about there? All right, there's just a little sideline there for you. Let me get over here. All right, I'm going over here now. I'm going to elaborate on item 2, the pivot clamp, all right? Just so there's no big deal to this, but let me lay it on you. This is the way I'm going to do it. I'm making, well, first of all, let me describe the material. See that word stress relieved? Don't confuse it with annealed. Stress relieved does just what it says. It takes all the stresses out of the material. When you remove material from it, it won't bend, twist, swap, do all that silly shit. It remains stable. It's a low carbon material, an A36 material, right? The thickness comes, this is the way it comes, -3 to +3 on a thickness. That's here, from here to here. And the width, -5 to +5. You see it? It doesn't mean that one end is -5 and the other end is +5. Whatever bar you get is parallel, but it could be anywhere in this range from one bar to the other, okay? Anyways, now what I'm going to do, obviously, is cut 4 pieces longer than what the print calls for, alright? I'm going to put them in a vise, and I'm going to put a stop. Not on the vise, on the table. I use a table stop. You can put the stop here on this side or that side, depending on what you want to do. I'm going to hang it out of the vise, square up one side, flip it over, hit the stop, and then hit the other side. I want to do the whole 4 of them off that stop. They all should be within 1 or 2 thousandths. Just giving that little background. Okay, using the same stop thing. I'm putting a stop on everything. Same stop, same place. Alright, operation number 2, I'm going to chamfer. I'm going to chamfer here, here, and here. Bottom and top. Alright, you're looking at the top view. You're looking at the top view here and the side view there. Here's the end view. You can see. Chamfers everywhere. Why? Because I like them. And it makes the pot look good, right? Alright, I do them. 4 pieces like that. Using the same stop. Now I'll take that piece and I'll put it in a vise using the stop setup. My drawing will give the coordinates. I always draw from the center. See where that mouse is? I give all the coordinates from there, up, down, left, and right. Alright? You can see them there, right? What are these? I'm going to show you what these 2 holes are for. You see it? When I'm done punching these holes in there, right, I'm going to stand this up in a vise. This piece, I want to turn it up 90 degrees, stand it in the milling machine vise, vertically. See this? 1, 2, 3 block. Wow. Alright? That red line shows the height of the vise jaw. Alright? What I'm going to do is stiffen this up so I can run an end mill in there. Let me do this. Oh, here we go again. This piece of shit. Oh, Jesus Christ. Okay, here we go. Alright, you can see it standing up in the vise, right? This is the height of the jaws. That's a little, it's taller. It's going to stiffen it up. The 1, 2, 3 block will be against the solid jaw, and the other jaw will push them all together like a sandwich, right? This should stand dead square on the bottom of the vise because you squared it up. Alright? Now over here I'm showing the 2 holes I drilled. They don't have to, what I'm going to do now is take an end mill, to 5/8 end mill, find the center, edge find it, find the center, and run it right through there. There'll be very little left over there to do that with. This here is showing a hole that goes across. The dotted blue line is the center, dotted red line is the body size. That's 1/4 inch, alright? Let me show it to you down here. You see it? That's 1/4 inch. Now I'm showing the slot without the drilled holes. This is a socket head cap screw, utility. Let me just drop it in there for you. piece of shit. As you can see, it's going to drop in there, and that's going to be pinned to the linkage. No threading anything. That hole is open. That socket end cap screw just drops in. It's just a hinge. You understand? I could do the same and show this end, but whatever. It doesn't matter. But that's basically what I'm going to do there. Alright. Now that I got all this bullshit done, I'm going to take it and put it on a rotary table. See the rotary table? First of all, before I get into this clamping shit, I'm going to show you how my rotary table is. My rotary table does not use a Morse taper in there. I took my table and I machined this diameter. You see it? Here. And I put a hardened bushing in there, liner, mold bushing, die bushing. It's hardened, and it's dead concentric to the movement of the table, right? How do I know? Because I rotated the table to make the size. You see the thing in the middle? It's called a pivot pin. Let me go over here. Before we get in the rotary table, here's what we're going to make. We're going to turn two diameters that are dead concentric, and it's going to have a 3/8/16 hole in the middle. That's an emergency hole. If you can't get it out or something's wrong, you can put a screw in there. You understand? And pull it out. See it there? All right. See this part here? That part in the middle? Item 2? I'm showing it here. Here's how we're gonna do it. I'm gonna drop it on the table. All right, babe. See, like I said, now I can clamp it right to the table, or put something in between, a little thin piece of aluminum, anything, just to keep it off the table so I can mill close without hitting the table. You see it here? All right, I'm gonna put it back. All right, so now what's next? I take this obnoxious thing. First thing I do is I take the table, and I take that. I'm gonna get these T-slots parallel to the axis of the movement of the table, right? I'm gonna turn this thing until it's on 0. Turn the hand wheel clockwise. When it reaches 0, lock the hand wheel. Make sure that this is in line. The T-slots are in line. Drop this critter on there, this part on there, right? Indicate this edge, right? Now, bear in mind, you got 4 of these to do. You don't want to indicate 4 of them. So once you get this, first you do is put this clamp on just gently. Indicate this edge. When it's good, clamp that down. Get another strap, put it right up against this edge and lock it. Now you can put them in and bump that stop, and you know that this edge is in the same spot on all 4 of them. Then what do? Right? Then you rotate the tape. Once you get it in there, I'll give you the coordinates. We put an end mill here. I think it's let me see what diameter is. Dimension, how it's on. Yeah, we put a 1/2 inch diameter at the coordinate I want, and then you rotate the table. This hole will already be there, so you rotate the table 53 degrees, 0.132, right? That'll make that arc nicely. And it'll do the same for that side. It's symmetrical. You understand? Now you'll have a shampoo on this. You can continue the shampoo on the table so everything looks good. You understand? That's the basics of what I'm talking about. Let me see if I forgot anything. No, I guess that's about it. That's enough for the planning stage. I can figure out, I can fill in the blank spots when I get there. All right? Hang on to your sneakers. I'm out of here. Well, guys, I'm going to wrap it up. Like I always say, thanks for watching. Have a good one.